Hello, I'm Yerang Lee. The project topic I would suggest is temporal action localization. So let me explain what this topic is. Simply put, the temporal action localization task is to predict the moment and type of actions in a video. As shown in the figure, when an untrimmed video is entered as an input, it is to find the starting point and ending point where the action occurred in this video, and to classify what action this action is. This task has been studied for a long time, but recently some attempts has been made to apply a transformer to efficiently utilize temporal information. In line with this project was also selected as a transformer-based temporal action localization task. This task is very similar to object detection. However, temporal action localization is a more difficult task compared to object detection because there are many frames with similar features around the bounding box in temporal action localization task. The dataset uses the famous dataset and consists of videos containing 20 sports actions, like baseball pitch, and there are 200 train datasets and 213 test datasets. The average action length is about 5 seconds, and annotations consist of the start and end points of an action and the type of action that occurs between them. Next, let's talk about preprocessing. Since the video is very large, it uses video features extracted offline. So it extracts video features for each frame using a commonly used two-stream I3D network. I will explain based on the model to be used in this project. Features are extracted in units of 8 frames and the stride is A2. Then each of the RGB and optical flow features is extracted and merged with 1024 dimensions. So in the end, a vector of 2048 dimensions is created. And the extracted video features are used as model input. If used as is, the model input size will vary and will need to be adjusted. So set the input length to 128 and set it to 64 stride for training and 96 stride for inference. Next, the baseline model is TED-TR. I will briefly introduce this model. First of all, this model consists of an end-to-end set prediction framework. Therefore, there is the advantage of being able to train the network without handcrafted components such as MMS. And it applied a transformer-based architecture using spurs of set in the video. The encoder models the relationship between different snippets, and the decoder predicts the actions class by modeling the relationship between action carries. A snippet here is a sequence of video frames. And this model, in this model, there is an action is regression step. This stage's goal is to extract context aligned with the interval of a predict segment and predict action is score opening. It consists of ROI align and feed-forward network like FFN. And then there is the segment refinement process with the decoder. It is a refinement mechanism to enhance locality awareness and improve localization performance. In other words, it adjusts the segments according to previously predicted segment layer by layer and update the reference points in each decoder layer. In this way, this model not only models the relationship between snippets, but also the relationship with actions. In addition, as a one-stage model, proposal and classification are performed at once, it results reducing computational cost. The implementation environment is as follows. This model is trained with 16 epochs with 16 batch size, and the training time takes about 10 minutes based on the Thomas dataset on Titan XP. Therefore, I think it is a model that can be fine-tuned enough. And the current performances of this baseline model are the MAP and average MAP values by TIOU can be found in the table. If you choose this project, you can upgrade the performance by applying a different transformer structure to the baseline model described before. Finally, here are links related to the baseline model and dataset. If you have any questions, then please send an email to contact information. Thank you.